So this project is going to be making something I've made before, namely a chuck key for my lathe. You've seen me make one a long time ago in another project for my 5C collet holder because I didn't like the chuck key that came with it. This time it's going to be a chuck key for the main 3-jaw chuck on my lathe, and the reason for that is because when this guy is in the chuck, the height is just barely clearing stuff, and I'm bumping stuff up here all the time. In addition, and even more importantly, is when it's down here sideways, so you'll have an indicator right here, and you'll be indicating something in. You'll make adjustments, and you want to make adjustments here rather than rotate 90 to make the adjustment. But the key is not long enough to go in here. So if I had, say, 2 or 3 inches longer out here, it would solve that problem. Also, I'm going to be making an interesting variation on this chuck key, and that will be that I'm going to be using aluminum for the main shaft and the arms. And you say aluminum, that's way too weak. But I'm going to be using 70-75 aluminum, which compared to a lot of steels, you know, cold rolled and hot rolled, it's stronger, has a higher tensile strength. So you might be asking, well, you got the square part here that goes in here, and aluminum's still soft and it's going to wear. That problem is going to be solved by the fact that I am going to be making an insert out of tool steel that will fit in the end here that will just have the square part. So I'm going to bore a 1/2 inch hole in the end here, and I'll be making a tool steel insert that will be pinned in the body with a square part machined in on the other side, and that should take care of the wear part. The arm is going to be also made out of 70-75 aluminum, 5/8 inch, so I think it should be plenty strong. We'll find out. This is an experiment, but I thought it might be nice to have not only a longer chuck key, but a really light one. And as long as I'm at it, I'll be making one for my 4-jaw chuck too, because this one's even shorter and almost completely useless. Plus, this shaft is just friction fit in. They just sort of roughed up the surface, but it slides all over the place. So I could drill and tap for a set screw, which I still can do, but this one's way too short as well. So that's where we're headed, and I will bring you back. First thing we're going to do is we're going to face this guy off and drill and bore a 1/2 inch hole for the tool steel insert. So I've never worked with 70-75 before, so this will be a new experience. It's supposed to not be quite as easy machining as regular aluminum, so let's just give it a shot and see how it works out. It's still not supposed to be too difficult, but we'll find out. It gets a beautiful surface finish like 60-61, so that's nice. All right. So let's chamfer this edge, just relieve it a tiny bit, and move on to boring. The boring part. I probably think I'm funny. We're going to take off 38 thousandths first pass. Let's get a measurement. Should leave me with around 25 thousandths if I remember right. 25 thousandths. So we will take the last 25 thousandths and be done. quick inside chamfer. Gotta say, this stuff really cuts in a wonderful way. Alright, so now I'm going to pop this piece between centers, and I'm just going to take a skim cut of the outside because I want it to be shiny because I love shiny. I know it won't stay that way, and actually this brushed finish isn't bad, but I still want to do it. So I'm gonna. There's 15 thousandths. Wow, look at that. That is beautiful material. We have the 1/2 inch hole in one end, and we need to flip them around now and put a 1/4-20 tap in this end and relieve this edge. I'm using this chuck because it's going to scratch the surface less, and then from there we'll go to make the insert for the other side. But first we're going to drill and tap for 1/4-20, relieve these edges. So with these 3-jaw chucks, sometimes you can catch the drill bit sort of in between the jaws, and the way I test for that is as I'm tightening, I rotate the drill bit and make sure that it feels like it's evenly grabbing on all sides. That trick seems to work for me. So I'll do the next one and I'll bring you back when we make the square inserts for these guys. So next we're going to machine this down to 1/2 inch, which will fit inside this diameter. It's going to be 3/4 inch long where 2 pins will go through. There will be a lip, and then it is going to taper down to a section that will be the circumscribed diameter of this. And by circumscribed I mean the circle that would fit right around and touch all 4 points of that square. And that is equal to the diagonal distance across here. That way I'll remove the maximum amount of material on the lathe here before I get to the mill where I will mill the flats. And then we'll be done with this piece that we'll insert in there. So let's get started. First pass, 100 thousandths depth of cut. And go for 3/4 of an inch. Just a little shy. Try and take this down to 1/2 inch. So we were at 1 inch, so we should be at 0.7 after this, more or less. So I'm going to try 125, and then we'll come back and measure it out. Be just a little bit bigger bite than I should take. The finish is kind of crappy. Oh yeah, that's a terrible finish. Pretty hot. 0.562. So let's try 30 thousandths. Depth of cut, new edge. Oh yeah, immediate finish improvement. The other one got a chip in it. Couldn't see it easily, but you could feel it. This is a much smaller depth of cut too. That's the kind of fit we're talking about. All right, wow, that's that is quite the fit there. All right, we're going to do that. We're going to stick with that. Just polish it up a little. Well, we still got to take it to the full length and polish it. So we need this to go all the way to set. We need another 50 thousandths roughly off of here. Here's one of the end pieces mounted. It's a very nice fit, nice piston. So what I've done is I've taken this piece and mounted it in here. So now we are going to take this and reduce the diameter to the circumscribed square, which is like 0.468 of an inch. The final thing, we will take it over to the mill and we will mill the flats. We're going to go in 0.6 of an inch to 0.468 inch and see if we can get that to diameter, and then we'll be ready for milling next. I was chipping my carbide, doing 100,000 passes for the small one. All right. 4673. Big bite now. Alright, that's actually pretty nice. Alright, next stop for this guy, milling machine, where we will mill flats this way, and we can take this piece and mount. So the next step is to pull these guys out of here and pop the 1/2 inch side into the collet here. If I can get that one-handed. Oh, hold on a second. That one's just slightly over 1/2 inch because of a screw up that I had to compensate for. This guy's a 1/2 inch, so it fits in easily. So, I'm gonna put these guys in here like this, tighten this guy down, then machine all 4 sides down to the final dimension, and then drill and pin this guy into this. And that's where we're at. So in order to get my zero back each time I pop this out, I'm putting in my my stop so that when I pop this out to rotate at 90, I can always come back to the same spot. Not that it matters because I'm going all the way to the edge here each time, but anyways. So we're going to take this down to a final dimension of 0.616 is the diameter. We're going to take the inside down to 0.468. So to calculate how deep I go, I take the diameter, 0.616, which is that current diameter, and I take the size of the square that I want inside, 0.468, subtract that from 0.616, divide by 2, the answer is 0.074. So we're going to go down 0.074 aside, and it should be right on the money. I decided to go full depth of cut, but take small bites and use a roughing end mill, or a roughing finishing end mill, which actually does a really nice job. Getting chips thrown at the lens there. Alright, so I left a couple thousandths on it just for the heck of it, just in case. And you'll notice that because we cut the the diameter first, there is just a little bit left of the curvature on the edges, which is a nice finish. All right, so we're going to center drill, and ream for the 0.125 pin. The 0.125 pins are about 1/2 thousandth over 0.125. So we're going to put one here. We're going to take this out, rotate 90 degrees after we put the pin in, and drill another one back another 1/4 of an inch, so we have a total of 2. So I've got some 70-75 handle material here, and I'm just going to face this side because it's not square, the other ones are. And then I'm going to round them over I've got this round over end bit, it's a 1/4 inch diameter, which should be exactly half, so I should be able to make that a nice, perfect semi-hemisphere, and I think that'll look nice. So it's a little bit of a risk trying 70-75 for the handle, because that's where all the torque is, but feeling this material, it doesn't really feel like aluminum, it feels much stiffer, so we're going to give this a shot. Alright, so let's walk this in by hand. I've got everything hunkered up very close to the edge so that it makes it maximum stiffness. Because at the end of this cut, it's going to be biting a lot of material simultaneously. I think that turned out pretty good. So I gotta flip it over and do it 3 more times. So I found a pretty quick way to do this. I start with the end that's nearly parallel to the outside, get it to just touch, and then just move longitudinally, slowly. Because again, remember, the bite gets bigger the farther in you go, until almost the entire cutter is biting, and we're done. Beautiful. So if you're wondering how this little 3/8 cutter fit in here, it's because I made an adapter a while ago, and this adapter has little Allen screws to hold the bit part in, and then the main screws hold it. So the next step is to drill a pip in the center of the handle that matches the diameter of the set screw protrusion. I chose that so that it wouldn't be able to rotate very easily in there. I thought it would hold better. So we're not going very deep, and so that's what we're going to do. We're going to find the center this way, the rough center that way, and give it a little bit of a drill. Silly me, I'm using a milling cutter, so I really didn't need to center drill it, because milling cutters tend not to wander as much. At least I don't think they do. I'm going to use the milling cutter in a drill chuck, which is weird, I know, but this is a pretty light operation. Okay, I think we're golden, so we will move on to the next one. Alright, so we're going to center drill, and then step up a few drills, and finally ream out at the end. Assembly is really straightforward. You just put the set screw in the end and slide the shaft in, align the pin with the set screw. Let me do that real quick. So here we are. I didn't make any major design advances. I made the handles a little bit longer, a lot longer in the case of the smaller one for the 4-jaw chuck. The shafts are significantly longer, and I made the ends out of stainless steel. I was going to make them out of tool steel, but I didn't have any 1-inch tool steel, diameter tool steel, so I used what I had, which was stainless, 303. I want to do that for wear issues. That was one thing I didn't know if aluminum would hold up, because it may be strong, but I don't know how it wears. It's probably still wears reasonably. So the big noticeable difference is that these much bigger ones weigh a lot less than the little ones, about half the weight. If we take it over here to the lathe, so the old one, I could use it straight up and down and a little bit side to side without hitting stuff on the top here. I couldn't use it on the side at all. It would not reach. So the new one, not only can I use it up here with lots of clearance, so I've got a lot more play, so if the chuck's not exactly up and down, I can reach it. But I can also use it on the side here, which is great. Plenty of clearance. So the same with the 4-jaw chuck. That'll be nice. You'll notice that this sticks out a little bit, and that's because I made it deeper to match the 3-jaw chuck here. And so I'm kind of excited. I will let you know how this goes. I think they're going to be able to provide plenty of torque, probably even as much as these guys, but we'll find out. I'll let you know how they wear and how they use, you know, how they are to use, and I'll meet you. I'll talk to you at some point in the future about what I think of them. I'm kind of excited though, because they are a lot lighter. That was one of the reasons you use 7075 plus. I like using exotic materials, and when I found out that 7068 was 30% stronger than this, I wanted to find that, but I couldn't find that easily, and that stuff is really expensive. Anyways, thanks for watching. Hope you enjoyed it, and hope to see you again. Thanks for watching.